How's it going, everyone? Eulier Gonzalez here. Right now I got some issue with the light bulb at my room. I hope I can fix that. But in the meantime, well, in today's video we're gonna take a look now at how can we subclassing with the class and extend keyword and understand how that works behind the scenes. And in today's video, I'm going to focus on the practical aspect of doing that as a way to now see how all of these things are connected each other and how that allows us to write is applications that are scalable using this particular approach, the object-oriented programming, which is a paradigm that in the 60s, a lot of people, the computer science, software engineers, come up with this idea and say, we need to find a way to organize the data and it is relevant functionality together, okay? As a way to, when we are writing our applications, we can now do that in a way that is scalable. Why this is important? Because after all, just to play the devil advocate here, when you make things scalable, it's like you can now have access, you can provide access to a lot of people that, if you follow is a funnel, you can, some of them convert into customers, or you can now expand your reach. So why this is important? Because 100 years ago, we didn't have now the ability to eat fruits that were not harvested or they were not from that place. So for example, it's very hard to eat bananas at Iceland or New York. But now, or avocados, right? But now, thanks to this scalability, this ability to now, if we're going to produce something, that's going to do that in a way that we can scale that, in a way that we can now provide that to multiple people, to a broad audience. So that's the reason of now, with the power here of this approach, the object-oriented programming, especially in JavaScript, and how that plays out, and see how the object-oriented programming is the classical object-oriented programming, and then understand now what is the nature of JavaScript, especially how JavaScript actually allows you to create objects, and then how you can now reuse your previous work when you write or when you wrote a particular object, how you can reuse your previous work in a way that now you can create specific use cases to cover is particularly needs. So by following this particular approach, we can now create and write these applications in a professionally engineering environment. So that's quite interesting, okay? Because in today's video, we're gonna see is that how this subclassing in class and extend works. This is a course taught by Will Sentence. A shout out to Will Sentence completely. Oh my God, yeah, this is to Will Sentence, Brian Hall, Scott Moss. Oh my God. But here is Will Sentence, the CEO of CodeSmith, which is a software engineer and machine learning engineering program residency headquarters in New York and California. So by looking at now how JavaScript, specifically the inner nature and how this object-oriented paradigm works in JavaScript, which is not the same in other languages like Python, for example, okay? So by now understanding this, we can now not only improve our analytical skill, how is our thinking process, but also, sorry, sorry, but also improve our communicational skills or technical communication skills. So can I implement your solution based on your description, based on your explanation, and then based on that, following is some good best practice. Sorry, Jesus. Following is best engineering practice. Develop your soft skills as a way to, hey, have patience, especially with new juniors or with yourself when you find a problem and you can solve that. Or be empathetic with other people. And lastly is with the domain specific knowledge. So we're going to make a quick recap of this course as a way to first understand is the object-oriented programming, the introduction of the object-oriented programming. How do we get here? And then the object creation, how now prototype works behind the scenes, and then using the new keyword, which is something that is on the ES6 scope. This, the default prototype change, how it works behind the scenes, subclassing factory with, and also with new class, and what we care about is with class extends and super. Okay. So first things first, the object-oriented programming is all about is how can we now organize data and it is relevant functionality together. Okay, so we can make our life much more easy when it comes to maintain this and scale to that. So with that in mind, we look at how can we create objects, okay, whether it's object template, object literal, dot notation, object dot create, or with the function construction. And by looking at how you can create that with a function here, this particular approach, anytime you create data and it is functionality, data usually is unique, but the functionality remains the same. And we have now duplicating is all of this functionality for every object that we are creating. So this is a good analogy. A good analogy here is like, instead of every time you forgot a key, instead of having 10 copies of those keys, one of these below your fridge, some hidden place in your car, some hidden place in your motorcycle or in your bike, in your motorbike or your bicycle, some in other in some beneath some plants outside of your house or somewhere inside of the couch. Okay, so instead of having all of this key, right, wouldn't be better to any time you getting in your house, you know where your keys are, and when you put that key, when you keep out that key in that place, well, you will know that you will find your keys anytime you get it. So that's the idea here. And the idea here is that instead of actually defining its own functionality inside of this function constructor, we're gonna pull out from there, create as an object, and then now link to that object as our methods, so we can now have this particular solution, which is actually the sophisticated way of creating objects. Okay, you have here now much more fine control about what's going on, especially when you're allowing a particular object, which in the case of the object that create, it creates an empty object, and then from there, now if you pass an object, it say, I'm going to make the proto reference of this, which actually whole is all of my reference, as a way to now access to the property and methods. I'm going to make this pointer here to the function object here, which is our function store, right? I'm going to point to that. So now this object that we're going to create, called new user, have access to the increment and the logging functions, as well as the property that we define there. So the whole point of this is to starting to see how now you can is create your data and your functionality by having fine-tuned control of what's going on behind the scenes when you're creating this link. All right, so because this is a process that you have to do over and over and over and over, okay? Especially you have to now create this link over and over and over. So wouldn't be a better way to actually automate some of this process? And that's where the new keyword kicks in and say, well, the ECMA developers, the ECMAScript developers say, or the ECMA designers say, well, this, my friend, this new keyword, it will allow us to automate certain process, and it's going to do things behind the scenes. A couple of things behind the scenes. First, it's going to initialize is this keyword as an empty object, and then it's going to assign all of the property that you now attach to this keyword. All right. Then look at the proto, which contains a pointer to, in this case, to the prototype, okay, function constructor, and then you return the new object. So for that, we need to define is the object with this particular way, and that is on this, okay, with the function user creator. It must be a function, all right, with the function user creator. That now you're going to pass is the reference is a solution 2 exactly, but we're going to look at the solution 3, sorry, is this one, okay, as a way to now look at how by creating this particular object, in fact, let's go to actually create that object for ourselves. No, can we do that here? I don't want to create that object here because after all, I just want us to dive deep into what is relevant for this for today's video, which is the class and extend. So this is how you can create now your objects with the data and its relevant functionality to work in this, so you can now have a one place to look at it, and by using the new keyword is automating those particular process. So this is great because when once you now can define is much more functionality inside of your prototype functions, you can do that, but there's some particular issues there, and that is the scope and this value. And I say that because it's like the first time when you started to understand JavaScript, it's like, what in the French toast is this? So you want to determine is that this is the value of this, okay? So because JavaScript is a dynamic language, okay, it means that the value of this have a different behavior unlike other language, and that might be quite problematic especially if you're new to the language, okay, especially if this is your first programming language. Oh my god, yeah, it will. But we are here is to actually now understand what are the finicky aspect of this scope and this. So what happens is that when we define nested functionality inside of those, okay, let me in fact actually here I'm actually going to create that function. So when you define is this nested functionality for yourself, let's say here I'm going to create it's a car, okay. Well, let's going to create a function here called car, okay, that's going to receive the name as well as the model. Okay, and then Here we would like to define is following is the new keyword. Hey, I want you to know the value of this, that when you are on a function, the value of this is whatever is on the left side when this function is invocated. In other words, you're gonna see what I'm talking about. So this dot name is equal to the dot name followed by this dot model is okay. So far so good. And then because we're using is the new keyword as a way to add our property, we're gonna do that under the hidden properties called prototype that functions has that function objects that built-in function object contains. So it not only contains a prototype, but also contains some other internal methods like call and bind and apply to stream. But for our case, what we care is the prototype. Okay, a prototype. And here we're going to define is, well, star engine, star engine. So this will be a function here. Okay, or you can define it as a star, right? You can say, hey, this is star. Star here is a function that what it's gonna do is just to say, hey, let me now define here and say, hey, this is now star. Okay, star engine, star, just like that, star. Okay, and another property here called prototype dot stop. Hey, so hey, or you can say is now you say increment kilometer. All right, increment kilometer. You can say is this will have is a kilometer, which is 0, right? This is one of the great things of this. And here we're gonna access to this kilometer plus 1. Pretty straightforward, simple functions. Here we want to define is this new car that is now a new, using the new keyword and the function constructor called car, where we're gonna pass is the, hey, this is the Toyota. And I get it why a lot of people actually they don't use, especially on the US, they are quite sensitive when using this kind of examples, especially right now. Anyway, so this is Toyota, right? Toyota, and the model is Hilux. I freaking love the Hilux, bro. Very robust car. So then now on new car, okay, I want to say, hey, let's going to call the increment kilometers. Okay, it's gonna call the increment kilometers, and I want to now console the log. Okay. Let me do this. I want to run increment and then take a look at the kilometer of this car. Kilometer. And this say is 1. Okay, so far so good, right? So what happened when we want to define now is nested functionality here. So for example, we want now to say, hey, star, but what do you want to start with? I want to start is the engine function. The engine. Okay. And this engine will say, hey, I'm going to now increment is the. It's going to add another property here called the this engine engine started, initially false, right? And all right, I want now to set is the engine to true. All right, so I want to access through this that's all. And I want to return is as here as an object is the engine, like that. This won't run because we need to define this a new instance, that kind of thing. All right, so what if I want now to run is the nested function, for example, new car, that is star, let's say star, but this star will return is once you run that, you're gonna have is an object called engine that I want to know is that I want to run is the engine here. Okay, so then I want to know if we actually start the engine of our car. So engine started. So you can see here it is false even though that we enter here in the function, but for some reason it's not changing that. And remember that after all, the rule of the this say, when you define that inside of a function, the value of this will be whatever is on the left side. And if there is nothing on the left side, okay, the value of this will be undefined. So what happened here? What happened is that now, for example, let me rerun this again as a way to refresh that. What happened is that when we want to actually see what is the value of this here, okay, we receive this as undefined. So sometimes the value of this when it is undefined points to window object, but in this particular case is empty, you know, it's not defined. Wait, what? Come on, let me now is the new car dot star dot engine, okay, and then actually see if we run our car, right? If we start the engine, engine started, okay. And as you can see here, well, the value of this is the engine, and engine started. Okay. But for some reason, it's actually not changing the object, not changing our data. You may wonder, well, but our data must contain is the name and the model, that kind of thing. So if you see, for example, hey, the new car actually contains is all of this, you know, but we are mutating is something that is not our data. That's interesting. So how can we solve this particular issue? By using is now the arrow function, okay, as a way to, with the arrow function, we are now saying, okay, so with the arrow function here, we are now being able to tell to this function as it is, hey, I want you to know the value of this be whatever is on the be whatever is was written. It means that the value of this will be the instance of our car. Okay, I want you to now point to that. What it's doing is just creating a closure. The reality here is that when you're using the arrow function here, the value of this here is now create a closure around its surroundings, where this now the closure is not only the prototype but also the property of that instance. Is the instance property. So now when we modify this, as we can see, we actually is mutate that as true, right? So if we want to say, hey, but I want to look at if this object really actually changed, new car, as you can see, the engine start is true. So we change the state here, but now we have that particular way of doing that, and we know what's going on behind the scenes. That's great. That's great. That's awesome. Okay, cool. So with this approach, now we can think of this data and its functionality here that can work together very, very well. Okay, and from there, as you can see, this is now the professionally approach, or something that you're going to find a lot of in code bases, right? A lot in code bases, because now we are able to organize our data and it is our functionality here into this object, so into one single place. So far so good. That's actually interesting and powerful. So what happened is that when we need, for example, define is this object using the class and extend, is actually doing this behind the scenes. So before going into the class and extend, first let me take a selfie. No, but first let me show you is now, okay, how can we make this subclassing as a way to now access to the property and data from other objects, okay? And from there, we're gonna see how that works with the object.create, so with the function constructor, with the solution to, okay? And then how we're gonna do that with the new keyword, and lastly, how that plays out with the class. Let's get into it. So for this particular example, we're gonna write is using the object.create approach, and that is, well, let's go to define our function. That this particular function will have if our user creator, okay, pretty straightforward. We're now here on the function user creator. We were able to now receive is couple parameters, name and score. Since we are now building this object with the object.create, we need to create is now a new object here by saying, well, let me define as a user new new user, okay, where here you say, okay, let me now use the object built-in, the object built-in in JavaScript that contains these couple internal properties and or hidden property, as well as internal methods. So internal methods like the create. here. So with the create, now we're going to tell to this new empty object created, I want the proto, the dunder points to the functionality. In this case, it's like points to, oh my god, no. Points is to this functionality that I have in this object. So let's going to create now this object with the user functions, right? And this will have is the increment as a function, where you can now have access is through this is this increment property that we haven't defined, but we're going to define, followed by the login. Hey. And here we're going to make our life much more simpler and say, hey, I want you to now just console.log this. It's like, hey, show this. New user, new user. I mean, you are logging. You are logging. Cool. Now I can indicate to this newly object created, initially is empty, set the proto of this object that you're going to create to the user functions, my friend. And then, well, now using the dot notation as a way to add some property to this new object created, new user dot score as well, score, and it's going to now return this object, which is new user. All right. So here we're gonna say is that, hey, I want you just to create this new user called new user, right? And run the function called user creator with the name of Bob, right? Score 23, right? And then now I want to say, hey, new user, I want to log in to this, to here. And there you got it. Hey, you're logging as a user. So far, so good. Now, what if we want to now define a specific behavior here, okay? As a way to say, well, it'll be way much more better, okay? Sorry. It'll be way much better to actually have now a pay user for that. How can we do that? Well, because we're using object.create, let's going to create now is first our construction object or construction function like a paid user. What we're going to receive is the name as well as the score and some additional property called balance that here is saying, okay, let me now call the base class, which is the user creator, okay? What I'm going to pass is the name and the score. This object that I'm receiving here, it'll be a object on the that it will be called pay or that I call new pay user, okay? Like this. Where now what I'm gonna do is this. Okay, this is now new pay user. So this new pay user, actually their proto is pointing to their base class, but I don't want to do that, at least not right now. What I want to do is to, when I'm going to create this new object, I want to point to my current functionalities. And then the current functionalities, the object current functionality from the pay user, I want now to point that to the use to the base class prototype. That's the proto change in action. Let's get into it. Yeah, let's get into it. Function pay user here. He was saying, hey, new. How can we modify is the proto? There is now a property called object.setPrototype. Before that, you have now to access to the proto and set that as it is, okay? But luckily for us, now we got is this set prototype of, which is a confusing name because at the end of the day, the browsers define this as the dunder proto dunder, not the prototype. But in any case, so I want to now make this current object here, which is the new pay user, to points to the user paid functions objects, to the functionality of this. All right, so with that, now let's going to create is this functionality, is this object for that. So comes user pay functions, which is an object that will contain is the increment balance, right? Which is a function that we're going to now increment. Oh my God. That we go now to increment is this dot balance property plus plus. And that's all. You may wonder, what is this balance? Where did this live? Oh, this balance actually we're gonna live is in this new pay user dot balance. Okay, so far so good. That's quite interesting here. So we're gonna assign the new balance, and then we're going to return is this new pay user. Okay. And now we need to actually indicate to the functionality, to this subclass functionality, hey, I want you to now access to the prototype of the base class, all right, or to the functionalities as well, which will be much better. So that's exactly what we're going to do with the object dot set prototype of. We say, hey, do you remember the user pay functions prototype? Yes. Okay, forget about it, and now points to the user function. So when we want to create now a new object here by saying, hey, this is a user one, okay, and say I want you now to create a paid user with the name Alice, followed by the score 25, yep, and the balance 10. And then I want to now see, well, call the increment balance, then check the increment balance from the user one to check out the balance, okay, right? And then now call is the login, because I want to log in this game for that. And there you got it. Look at all of the process that it took me as a way to only create is this inheritance. Oh my God. Or this link that can have access to the property and data. So that's quite interesting. Also quite lengthy and verbose, I must admit. And this is the sophisticated approach of how you can create subclassing. Now, if we go to look at how you can create subclasses, not with the object.create, but with the object or the new keyword, well, because I don't want to repeat myself, not at all. I mean, no. Let me see if I actually have the code here. Don't tell me that. Subclassing with factory functions. Okay, there you go. There, of course. Good. Okay. So this is now how we define our objects with the user. Okay. With the new keyword, we define the constructor function where our data will live. We're gonna separate that with our functionality, where now here we can say is under the prototype we're going to define all of the relevant functionality. But now, because new is actually automating this particular process of referencing things and that kind of thing, how can we now create subclasses using the new keyword? Glad you asked, and if you don't, no problem. Here's the answer. So, is this. You say, because we want to create now a subclass with the new keyword approach. First, we need to define is this function. You know, this thing slowly becomes repetitive. Okay, quite mechanical. Once you know a technique, it actually becomes mechanical. But you need to understand what is going on. So here we got is a pay user, right? With the name and score and the balance, pretty much like we did before. Okay. And well, we got our this thing to actually create our object. But because we're working with the this, how can we now actually call the base class and then underneath the hood update the this value? Because after all, the this value is actually is what is the new keyword is going to return for us. This new object that will contain is the property. You're going to perform is the reference. You're going to update the proto reference to the prototype function constructor, okay, where in our case is the pay user. And with that, then we're going to return the object. But we are not able to call this new keyword, right? We cannot call new keyword here and find that. We're going to receive is a new object, but we don't want. We're going to receive that. We're going to receive is this new object with the prototype now changed. But we don't have access to the prototype, or at least we don't have now an ability to get access to the prototype, or at least as far as I know. So instead of using the new keyword, we're going to do something finicky about it, which is, because we are now doing this subclassing, let's now create the user one, or is called the user creator. And we're going to call is this function call here, and we're going to pass now the first parameter is the context of this as the this, okay, followed by it is argument, name, score, and balance. So the subtle difference between the call and apply is that the way how they receive the arguments. Call receiving a comma separate value, bind as an array. And because these functions exist is on the function object, from this built-in function objects, all right? So it has inner properties like length and call and constructor, as well as hidden or inner hidden methods. No, it's not hidden. It's inner methods or inner inner methods, inner methods, which is call, apply, bind to string. So once we do this, because at the end of the day, when we run this, what we're gonna get is the value of this updated as a side effect, which is one of the finicky things of JavaScript here. You're calling this, and as a return, you're gonna get this in the new function constructor updated. So once you get that, all right, now it is time to say, how can we now here is to make that this object points to the relevant property, points to the relevant how can we make these particular functions to point to the relevant functionality here? That's the entire thing. Well, we can use here again is the object dot set prototype here as a way to say, well, this object that we are creating, like the pay user, okay, I want you to know the product of this points to the functionality. But we cannot do this here. We need to do that is outside of that. We need to do that at the function level, to the pay user. So that's how we say, well, after you define now your other properties like balance here, now it is time to, well, access to the pay user dot prototype, okay, and first you can do something like this. You can do the pay user prototype to make now to this actually point to the prototype that we're going to define here, which is in our pay user prototype, that we're going to now point to that, to the actual functionality that we want to, which is a user creator dot prototype, right? Prototype that actually whole is a reference to that, you know. Which this user creator prototype contains a reference to the functionality, and then we define is our functionality here under the prototype, right? We say, hey, the prototype here is the current functionality, which is well, let's going to create this like increment balance, right, as a function. That's right. And then this function will be like this. It is the this dot balance plus plus. And now when it comes to create this new object, we're going to use a new keyword, paid user, with the name of Bob, with score 5, a balance of 10, okay, and we're going to assign that to a cons here, which is the user 1. So this user 1 now we want is to first increment balance, call to this method, and you can walk through this entire process. So JavaScript now is saying, hey, let's want to evaluate the increment balance here, okay. Let me now look up the increment balance. If that exists in our objects, no, does not. So let me take a look now at the prototype. Yes, we have that increment balance. Then run it and execute that. So the same for user one, with as a way to actually look at our balance here. I want to see where, at which state our balance are. Console log here, and then lastly I want to log in to the game. Redeclaration of cons user, yep, there's no surprise. Let me refresh this, paste this. Redeclaration of cons user, yeah, okay. So we say pay user. Now pay user in this case. It's pay user. Okay. And here we are. Hey, you're logging. We're not able to show the balance. Hey, you're logging. This is the way of how you can do subclassing using the new keyword. As you can see, it's something that is actually quite time consuming. Totally. Why this is important to understand behind the scenes? Because most of the time we are going to now is build objects where we're gonna build this object. We want us to build this up. We want us to not focus how this inherited linking process or way of how can we access to property from another objects. Actually, we don't want to set that mechanism. We just only want to focus on what really is important, and that is on writing code, writing applications that have some impact. So we don't want to actually dedicate our time or effort in something that we might, even though that we have fine control, but it takes time to actually do this. And time is one of the most important resources that a software engineer has. So now that we make this particular approach with the new class, with the class keyword, with the class and extend keyword, all of this process that takes quite amount of line here, it can be done into this class, which is a special type of function object of the user creator. But because we are using now a class, this is the way of how you can define is your user. This is some convention as a way to indicate to other developers, hey, this is a class, bro. Or this is a constructor, function constructor. So here the anatomy of this is that you can define as a constructor, and there can be only one and one only constructor with the name and the score here. And the constructor, what you're going to do is to, as the name suggests, construct, initialize this object with some dynamic data by using is the value of this. Okay? So now here, this is when behind the scene it will behave similar to the older or to the new keyword prototype. So with this class syntax, we can now define is the name property, okay, the score property on this object, all right, and then our methods here, such as increment score, or increment score, increment, where now, because we are here in the class context, the value of this that is inside under the class or under the methods, it will refers to the instance, which is that this value will refers to the instance. So this dot score, I want you to increase that, and then define another public here, and define another public method. First we define is our public, what is the name of this? Let me actually press that. Public fields, exactly. We're defining is the public fields, like that. So we're defining is the public class field, public instance field. Okay, so this is the instance field. The value of this will be is the instance value, which is great. Okay, and on this login method, we can now define is our console log as it is, right? So hey, you're logging in. You are logged in. You're logged in. And that's all. Less verbose. It looked like class OOP, but the reality is that it's doing this prototype inheritance or prototype object accessor. So that's great. That's quite interesting, because with this particular approach, now we can say, all right, I'm going to actually create a new object here, which is user creator. When we pass is the name Alice. Oh my God, Alice. All right, and the score 25. So when this will run, okay, when this now class run, it will behave pretty much like the constructor. So for example, here in the constructor, let me see is what's going on when we use a new keyword. Here, when we run is the new constructor. Exactly. But as you can see here, they all behind the scenes is running that. Classes can only be instantiated with the new keyword. Attempting to call a class with the new will throw a type error. Creating an object with a user-defined constructor function requires two steps, this and this. That's one of the reasons of how you need to define that, because the new keyword, it will look at that function constructor, where in our case is this nice method that must be only have one, and it's doing is, well, I'm going to create this empty object here first. Okay, I'm going to create this empty object first here. I'm going to update the proto to points to the prototype of the function constructor, which in our case is all of this increment and all of these public methods are defined under the prototype. Okay, and then it's going to return this new object, which is, hey, this is the user one, and assign that to this. So when we gonna log into our game, we are now able to log into our game. Look at how clean is this. It's a lot of less code, but there is a lot of machinery behind the scenes, machinery that we need to understand what's going on to move on to the next topic, which is what we care about, and that is subclassing. let's get into it. Oh my God, yeah. Let's get into it. Let's get into it. Let's get into it. Let's get into it. Okay. All right. So you may wonder now, how can we is, for example, access to property and methods that we defined before, for example, the user creator, with our new keyword, with this syntax as it is. So, luckily for us, we can define as the class, in this case, paid user creator, okay? And here, because now this will extend. So extend is a powerful feature. It's a very powerful feature because it's now allowing us is to bind the prototype from the function constructor to the base class, as well as the prototype from this class, from this subclass, to their own prototype functionality. This is a very powerful thing that is doing here. And this keyword here is doing a lot of things for it. It's actually do all the heavy lifting of linking. Do all the linking heavy lifting. I really love it. Totally, man. So let's go to see what's going on here on the extends. Extends. So extend keyword is used in class declaration or class expression. And the class declaration is when you define that as we did here. And a class expression is when you assign that to a variable, okay? To create a class that is a child of another class. And you may wonder, it's like, okay, this is a child, this is subclassing, how that works behind the scenes. Because here you're gonna say, hey, this is my parent class, okay? And perhaps this is a concept that a lot of people, especially in the industry, they tend to find that quite hard and quite boring, and quite challenging as well. When they say, hey, I want now to make this thing a little bit less annoying, a little bit less annoying when it comes to access to the property and method that we need to. So extend from the parent class from the body of the class. So the parent class is an expression that evaluates to a constructor function, including a class or null. And this is something interesting because it's now evaluating, so an expression that evaluates to a constructor function. Hey, is this parent class? This is what it's doing behind the scenes. Take a look at this. Is that, hey, parent class, I'm going to evaluate if you have a constructor function, okay, including a class or null. And the description. The extend keyword can be used to subclass custom classes as well as building objects. So you can say, hey, not only is my custom classes, parent class, or building objects, it's like, hey, I want you to know this class inherit from or can have access to the math object, can have access to the regex or the array structure. You know what I mean? Most likely is this particular building objects. Building objects like building objects here, like usually is it can be date. I prefer to look at the static static built-in object, standard built-in object. Well, any case, but for example, we want to have access to the static method, like date, parsing, UTC, right? In the case of date, or another example is that, hey, I want you to now extend from the another JavaScript building object. Okay, like math, usually, or yeah, but it's like this, you know. It can be window, it can be all that kind of things. Like that's quite interesting. All right, okay, cool. So, anyway, okay. So what I'm gonna do here, okay, is to now, well, by reading is the extend, what the extend actually does behind the scenes, like this, is now evaluate to a constructor function. So in other words, we can say, hey, extend from the a constructor function, like we can say is this. This is a constructor function. Let's say user where creator. Okay, where now here it say, hey, this where prop, or you can say is a user, instead of user where, is say a user function constructor. Okay, and then you say, hey, this is this as a way to have access to this property. Say this props, you know, or this pro. Okay, this dot user constructor. This is a function constructor. Okay, a constructor, and we can also pass this the name for that. All right, as well as the user, as well as the exactly the name, and let's go and say the score. Okay, score. So we can say he's now, since the extend is going to evaluate this, the name, which is the name, and the this dot score, which is the score. That's right. Okay, so this is a function constructor, and this dot name, this is a score, and here the extend is going to evaluate to a function constructor. So it better be that this user function constructor actually is a function constructor. Okay. So the extend keyword can be used to subclass custom classes as well as building object. Any constructor that need to be called with new and has the prototype property can be candidate for the parent class. Okay, any constructor that can be called with the new, in our case, it has the prototype property, because at the end of the day, a function constructor contains is the function as well as the prototype that can be candidate for the parent class. The two conditions must both hold. For example, bound functions and proxy can be constructor, but they don't have a prototype property, so they cannot be subclasses. That's interesting. So as a way to actually you have access to the property method, because it's required the extents to have the prototype, okay? As a way to have access to this function constructor, that is any function that can be run with the new keyword and also have a prototype, because it's under prototype where we put all of our functionality, like this. But they don't have a prototype property, so they cannot be subclasses. It's interesting. So, exactly, the function constructor as well as the prototype, this is when you can now extend from the old style class. Look at this. The prototype property of the parent class must be an object or null. Okay, but you will rarely worry about this in practice, because a non-object prototype doesn't behave as it should anyway. It is ignored by the new key, by the new operator, like this. So when you now want to access to the prototype exactly of this new parent class, this must point to the prototype itself. Okay. So extend set the prototype, exactly, extend set the prototype, or in other words is the proto reference. Extend set the prototype for both the child class, because after all this is interesting. So the extend set the prototype of the child class, okay, which is where you're going to define all of your method and property for this base class, as well as from the child class prototype, which means which means is that it set the reference to the prototype exactly. Extend set the prototype for both, for child class and the child class prototype. Extend clause option, prototype of a child class, prototype of a child class prototype. Exactly. Prototype of child class. It sets the prototype of the function, okay, of the current functionality, and it set now the prototype of the object prototype to links that links to the base class. Extend null function.prototype and the object.prototype. Remember that after all, class is a special type of object. It's a special type of function, and this function, the anatomy of this is this object function. So the object aspect has the prototype, okay, as well as the function itself. Object.getPrototype. Exactly. If you do something like this and a class with this, and if you want to get the prototype of the child class and compare it to the parent class, okay, allow inheriting of static properties, allows inheriting of instance properties. Okay. Of a static class and the instance prototype. The right hand side of the extend does not value to be an identifier. You can use any expression that evaluates to a constructor. This is often useful to create mixins. That this value in the extend expression is that this value in the extend expression is that this surrounding the class definition and referring to the class name, and referring to the class name is a reference error because the class is not initialized yet. Await and yield work as expected in this expression. Some class, which is that extend base class and the derivative class. While the base class may return anything from its constructor, the derivative class must return an object or undefined or a type error. All right. Okay. Okay, but when calling a static factory method like promise of result or an array from on a subclass, the return instance is always an instance of the subclass. The standard committed now holds the position that the built-in subclassing mechanism in previous spec version is over-engineering and causes no negligible performance and security impact. New built-in methods consider less about subclassing and engine implementations are investigating whether to remove certain subclassing mechanisms. Oh my god, and they are proposal to remove. Okay. Suyu Wu on Google. Yeah, okay. Subclassing instance creation via species is built-in method array. To be one of the 39 greatest mistakes for the language. It imposed great complexity on implementation and mental model of the language, the cause which has resulted in many security vulnerabilities. This proposal seeks to remove subclassing support via species and related machinery, such as property lookup of flags and exit in certain regex. This is a significant fix, fill or kill. Fill or kill. Backward incompatibility change that seek to remove all built-in subclassing machinery. Doing finer grain removal for certain method of construction will result in more confusion and does not remedy the complexity and maintaining burden costs. Supporting subclassings in built-in via species and related machinery incurs significant burden, increased implementation complexity, and maintainable. Taxonomy of subclassing. Without type 1, and doesn't support new target, the following will be true. Okay, return a type array. Cost benefits. There is crucial dependence on type 1 subclassing, and it is worth implementation in language costs. Type 1 is used by user libraries as well as by web platform in WebADL and DOM. Type 2 subclassing instance creation and building methods. Customizable subclass instance creating and building method. Delegation to property lookup and building method. Propose new old semantic. Oh shit. Consider using composition instead of inheritance when enhancing built-ins. So even that, they are now pushing towards that. Holy moly. Yeah, they are pushing towards that. God damn it. God damn it. Oh shit. Is not web compatible. These proposals have been withdrawn. Okay. The designers, man, they got the goat. Alright, okay. So what it's doing is to now evaluate to a function constructor like this. And then this is what it's doing extend, right? So extend, what it's doing is to set the prototype for both the child class and the child class prototype. which is the function.prototype, which means that it is own functionality and the functionality from the base class. And the functionality for the base class. So by doing is this, okay, and the other is super, something that you don't define here, which is to me quite interesting, that you don't define this extending null. Using extend as the polygon, extending plain objects, extending building objects, exactly, extending building objects, extending object itself, no, because it's an object. Species. Okay, to override default constructor. Exactly, see the build classing. Exactly, subclassing built in. It's like new built-in method consider less about subclasses than engine implementators are investigated whether to remove certain subclassing mechanisms. It's like, well, you shouldn't do that. you shouldn't do that. Avoiding inheritance. is that it breaks the design, the list substitution principle. It's like this base class, if we to guarantee the interoperability of objects. So, for example, if I create a new subclass that extends this functionality from the base class, I must have now, or I should have the ability to replace this new subclass with the replace this new subclass on the base class, which states that subclass should be substitutable exactly. So subclass must be substituted for its superclass, or should be substituted. Okay, which states that subclass should be substitutable for its superclass. If a function expect a map object, it should be able to use a read-only map object as well, which will break here. Inheriting often leads to circle elliptic problems because neither type perfectly entails the behavior of other, although they share a lot of common traits in general, unless there are very good reasons to use inheritance. It is better to use composition instead. Composition means that a class has a reference to an object of another class. So instead of actually is, okay, but composition means that a class has a reference to an object of another class and only use that object as an implementation details. That's pretty fucked up. Read-only map, private data, construction when you're gonna pass this, which is a private data, where you're now going to create a new map values for this get, hash, and get, and keys. Anytime you call the key, it's going to return is this new particular iterator protocol where you can now use the for loop game. So where you can use the for loop as a way to iterate through that. In this case, the read-only map is not a subclass of map, but still implement most of the same method. This means more code duplication, but it also means that the read-only map class is not strongly coupled to the map class and does not easily break if the map class is changed, avoiding the semantic issue of building using. Exactly, avoiding the semantic issue of built-in subclass. For example, if a map class adds an in place, what the hell is this? What the hell? Map.prototype in place. Motivation. Adding and updating values to a maps are a task developers often perform in conjunctions. There are currently no map prototype methods for either of those two things, let alone a method that does both. The workarounds involve multiple lookups and developer inconvenience, while avoiding incurring a code that is surprising or it is potentially error prone. We propose the addition of the method that will add a value to a map if the map does not already have something at the key, and it will also update an existing value at a key. It is worthwhile having this API for the average case to cut down on lookups. It is also worthwhile for developers convening an expression of intent. Giving counts in the maps of objects ID, insert or update. Normalization of value during insertion. And this is one of the beautiful things of this functional approach. Is because now we don't need to worry about what we have to do, what we have to check. This actually is abstract what is doing behind the scenes, so we can now do this kind of this. Either update or insert for a specific key. Update and insert. Okay. Two lookups. Compute is present. Compute is absent. Set default. Oh, that's interesting. Okay. So for example, if the map class adds an in-place method that does not call set, it will cause the read-only map class to no longer be read-only, unless the later is updated accordingly to override in place as well. Moreover, read-only map object does not have set method at all, which is more accurate than throwing an error at runtime. Okay. This is now the extent, and what is doing the extent of that. And the other is super. Oh fuck. And the other is super. Yeah, and the other is super. So super keyword is used to access property of an object literal or class prototype or invoke a super class construction. So with super it is used to access property of an object literal, okay, or a class prototype. Hey, I want you to now is access to the prototype. I want you to access to the methods of this class prototype or the object literal. So the super.prop and the super expressions are valid in any method definition in both classes and object literal. So the super R expression is a valid in class construction, because now it invokes the super class constructor. It invokes the super class constructor. Okay. It invokes the super class constructor. Here it calls the parent class constructor with length, provide for the rectangle width and height. Now, in derived class super must be called before you can use this, moving this to the top cause as a reference error. It's like, yeah, do you with super actually updating is the value of this? Okay. It's like this, you can now make use, it's like returning is the value to the this value. Using super props in object literal. method that read the super props does not behave differently when bound to other objects. Calling method from super. Okay. Okay.
If you overwrite it with null, that super ain't gonna do anything. Okay. Let's see it play out. This is a lot of laying out. We're gonna see it play out and that should become a little bit clearer. Right. Left hand side here, Chris, what are we doing? We set up our whole paid user class with it as an extension of user creator. Now we're gonna declare what?
A constant of paid user.
Yeah, perfect, of paid
User one.
user 1. Are you ready for this? I'm ready for this. This is our final code, folks. Paid user 1 is 25. Okay. And that, what am I playing about? And now we're calling the new keyword. Nick, this is your specialty area. What does this get us doing? Oh! I can't help you out this time. It's not your specialty area this time. Because now in a class it does do something weird. So there is a this assignment, but it is uninitialized. Nothing there. Okay? And we immediately must have a super call before we want to refer to that this. It is there, it's uninitialized, but we cannot refer to it. It's not undefined. We can't go console log above the super, which is hopefully going to go and call the user creator to create our underlying object. We are not going to run user creator and have it have a side effect on the this we create with a new keyword here. No, this fundamentally changes the class structure, how and where our pertinent object, the one we're creating, that will eventually be stored in page 1, is actually being born. It is not being born in page creator. It is actually going to be born in user creator. And that is a design decision of the JavaScript team to make it be born in page creator. To make it be born in user creator constructor function. It is born in there. And then it is automatically returned out and assigned to the this out here. Versus, remember in the previous version, we had side effects on the object we created here. Okay, so let's start doing this. So we're going to call, so it's unassigned right now, uninitialized right now. We call super with what arguments, Chris? And they're going to go into, and what parameter argument combos in the constructor? Name is going to be a lissert, store is going to be, this is going to equal the return value of calling super. Now, I'm going to actually show you briefly what actually happens. It does this. There's a new thing in JavaScript that allows you to call a constructor function, a function that should have a new keyword in front of it, that allows you to do it without the new keyword. It's called like reflect.construct. Can someone type that into Google? I think Mark, you might type reflect.construct, it's in MVN. Reflect.construct. I'm actually going to show you what this exactly does behind the scenes. I'm going to do it in red because it really is about the extents that make this happen. Okay? So it's going to be reflect. Does it say?
Do you get that, my friend? When setting property through super, the property is set on this instead. And if you want to take a look now at the ECMAScript script as a way to understand a little bit more about the super nature. super call. The super keyword completely. Let the end be the get this environment. Let the actual this be the end get this binding. An environment record. Declarative environment, function environment record, model environment record. Okay, an environment record. It can be declarative environment, a function or a model, an object environment record, or a global environment record. And because at the end of the day, everything is an object, it's going to return is a class object here. Okay. The following step when called, let in the running execution context, lexical environment, repeat. But it's going to return is the environment record. If find the environment record that currently supplied the binding of the keyword this. It perform the following step when called. So it provide you this now object runtime semantics evaluation with an expression, with an identifier name, or with argument. Make super property reference. Make super property reference. Super reference record. This value. Return the reference record, base, reference name, string, and this value. Argument list, runtime semantic, argument list evaluation. But it's actually returning is the value of this. Okay, god damn. Well, that'll be all for this video. Take care. Bye bye.